So the Chem Limited produces two products, namely alcohol and xenon. So we have alcohol and xenon. So the product here, products, we have alcohol and then we have xenon. Yeah, the final product. In linear programming, we must always start with the final product. So we have alcohol and xenon. The products pass through three departments, namely assembly, finishing, and the packaging. There is maximum of 200 hours in each of those three departments. In addition, a maximum of 400 hours of packaging are available for packaging alcohol and xenon. The table below shows the number of hours required per unit of each product. So we start with assembly. So objective function, you write here, objective function will be to maximize total profit. And below that table, there is a statement telling us each unit of alcohol and xenon gives a profit contribution of 3,000 and 2,000 respectively. So you can see in this case here, we have profit per unit. So profit per unit for our product, we are told that alcohol is 3,000 and the xenon is 2,000. So we have here 3,000 per unit, 2,000 per unit. So remember, at the end of the day, if you look at the question very well, the question, they want us to formulate a linear programming model to solve the above problem. What is the problem? The problem pertains to the number of units of alcohol and xenon that should be produced, of which initially that quantity is not known. So we let the quantity here to be x1 and here to be x2 or xy, doesn't matter. So remember, this profit is per unit and these are the number of units. So the objective function will be 3,000 x1 plus 2,000 what here? X2, like that. 3,000 x1 plus 2,000 x2. So that is the objective function, is to maximize Z, which is total profit. Remember, this given here is profit per unit. Then we come and write our constraints. We write our constraints here. So we have subject to. So the first constraint is the department known as what here? Assembly department. So we have here assembly department. So assembly department, we can see the hours. I can see alcohol needs to, and I'm going to make in this case here x1 alcohols. So 2x1 plus, and the assembly, 2x1 plus, then we have xenon. Xenon, you can see there, and the assembly is 3. So 2x1 plus 3x2 should be less or equal to, they told us that assembly and the other departments, each department, we have a maximum of 200 hours. So there is no way we'll be able to exceed the 200 hours. We can't exceed the 200 hours. So this is the assembly constraint. Assembly constraint. So up to here, can I get in this case here some endorsement telling me whether we are together, really? Tell me whether we are together. Are you able to follow? Are you able to follow? Great. Thank you so much. So then kindly go ahead and write for me finishing. So number 2, write for me finishing department. So I can see the finishing department. Finishing department, I can see the usage per unit. So finishing department, I can see under finishing department, we have 4 and 2 across finishing. 4 and 2 across finishing. So 4x1 plus 2x2 less or equal to, again, it is 200 maximum for this department. So go to the second last. Second last, in this case here, is known as packaging. The second last is known as packaging. Packaging. So packaging, what are we seeing there? I can see the line of packaging spread to the 2 products. So we have here 5x1. We have here 5x1 plus, in this case here, 3 plus 3x2 plus 3x2 less or equal to, let me read again, ladies and gentlemen. What are we told here? We are told there that there is a maximum of 200 hours in each of the assembly and finishing departments. In addition, a maximum of 400 hours of packaging are available. So for packaging, we have 400. We do not have any other constraint other than now the non-structural one, the assumption one, what we call the non-negativity. That our x1, full colon, x2 should always be greater or equal to what here? Should always be greater or equal to 0. The negativity, x1, x2 should be greater or equal to 0. Greater or equal to 0. So in this case, ladies and gentlemen, if you have been able to write up to here, could you kindly place like what I can see this ninja called 𝒂𝒂𝒄𝒄. In this case, you're putting the thumbs up. You're able to follow and say, I mean, this formulation is correct. If you're saying this formulation is correct, can you kindly put like this, your thumbs? Yeah, great. Then, ladies and gentlemen, having discovered this is now correct. We are through with number 1. Look at number 2. Number 2, using the simplex method, this examiner has assisted me. They want me to get all the marks. Using simplex method, in this case here, go ahead and solve. Great examiner. So the only thing that I need to do, my good students, is to come and do the simplex formulation, you know. So come here and give me the simplex formulation. Give me the simplex formulation here. I'll just write it here. Simplex formulation. Yeah, simplex formulation. The simplex formulation doesn't have these inequalities. Yeah, instead of these inequalities, what are we going to add in the simplex formulation? Instead of the inequalities, less or equal to, yeah, the slacks. Thank you so much. The slacks, yes, because these are less or equal to all of them. So we normally begin with the subject 2. So we have the first one over here, 2x1. Yeah, so we have here 2x1 plus 3x2 plus slack 1 equals 200. And then we have, ladies and gentlemen, 4x1 plus 2x2 plus slack 2 equals 200. Then we have here 5x1 plus 3x2 plus slack 3 equals, in this case here, 400 like that. And then now you come and finish with the z equation. Finish with the z equation. So you can even write here, z, it doesn't matter, take this to the other side. Take this to the other side. So z minus 3000 x1 minus 2000 x2. You say equals what? You don't have to like arrange all of them. It can be like that. So in this case here for the z equation, which normally is the last, we shall take the other terms, the other side. We take these terms the other side, and then we shall be able to come here, ladies and gentlemen, and rub this. From there, we write initial simplex table. Initial simplex table. So we write there initial simplex W. Or just table, the normal table. But if you have to scale the examiner, call it W like that. Initial simplex table. So initial simplex table, my good students, what do we have here? Very easy. You will be able to come here and have the variables x1, x2, and then you have introduced this s1, s2, s3, and then of course you have a foreigner here called z. So long as you don't forget it, you have a foreigner there called z. And then you'll be able to come here and write right-hand side value. 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 Remember, right-hand side values are these ones here. Because this left hand, this is right hand, like that. Right hand. While the negative in z, we must always tick. You know, here on this side it was positive 3000. When it crosses over the equals, it has to be negative. Don't forget the negative. If you don't have the negative, you'll get a 0 in the entire question. So then we bring here the coefficients. So like the coefficient of x1, equation number 1, this is 2, this is 3, this is 1. And then we don't have s2, so 0. We don't have s3, 0. No z is here, 0. But we have the right hand being 200. We have the right hand side being 200. Yeah. Is there somebody who is able to post a second equation on their own? Anybody who is able to post the second equation on their own? Oh, yes. So we have here 4, x2 is 2. I can see s1 is not here, so 0. But s2 is here, 1. s3 is 0. We don't have z here. You kill it, 0, 200, like that. And then you come to the third one. x1 is 5, x2 is 3, 0, 0. S3 is 1 because we have S3, 0 here. All right. Then you come here. Do we have x1? Oh, yes. And it is negative 3,000. It is negative 3,000. Minus 2,000. Yeah. We don't have any S here. So 0, 0, 0. No S3 there. But here we have Z. So 1 there. And then we have, in this case, 0. Sorry. Here, I forgot to write 400 here. I forgot to write 400 there. So up to here, ladies and gentlemen, are we okay? Thank you so much to see. At least I can see to see giving me things there. Yeah, so up to there, are we really together? Great. So from there, we ask ourselves which question. Can somebody guide me? We ask ourselves which question. We ask ourselves which question. Now, these students who are missing these classes, do they ever get to watch these videos? I don't know, because your class has about 250 students, right? Your class has about 250 students in total. But normally we get 30. Yeah, we assess this for optimality. And we can see, so assess the above for optimality. Assess above for optimality, This cannot be the best table because not the best. Not the best. Not the best simply because we have losses. We have negatives. How can it be the best and I can see losses? So above table is not optimal. It's not the best. So go ahead and make another table. So if it's not the best, identify, normally the losses, we observe losses from the Z row, normally, the Z row. So identify, in this case here, the highest loss. That is the one that I would want to treat. Because when I make these tables, I'm doing treatments. So the one that I would want to treat, because you treat one thing at a time, you can't treat both at the same time. So in this case here, the highest loss. So highest loss is negative 3,000. Is that okay? In the Z row, in the Z row, the highest loss is negative 3,000. Is that okay? Yeah, can even see Miss Wambua has been able to identify it. So once you identify this as the highest loss, what should be the next thing to be done? What should be the next thing to be done? There must be some circling. Thank you so much, Faria. Great. Faria has been very consistent with my classes, very consistent. So having identified this minus 3,000, what should be the next thing? Circle the pivot column. Yes, we circle the pivot column. The column of the biggest loss will be called a pivot. So this is what we call PC, pivot column. So having gotten pivot column, what do we use pivot column for? What do we use pivot column for? To get ratios, right? So come here and give us the ratios. Give us the ratios. So how do we get the ratios? We take right-hand side divided by pivot column. Right-hand side, you divide by pivot column. So these are the right-hand side. So 200 divided by 2. You take the right-hand side, you divide by the pivot column. So 200 divided by 2, this gives me 100. 200 divided by 4 gives me what here? Is it 50? 200 divided by 4. 200 divided by 4 is 50. Yeah. And then we have here 400 divided by 5. So that gives me 80, isn't it? 80. Thank you so much. And then remember, we don't calculate ratio for the Z row. We don't calculate ratio for the Z row. Thank you so much. So once we get the ratios, What do we do them for? Can somebody in this case here tell me the meaning of these ratios? What shall we do? What shall we use these ratios for? What shall we use these ratios for? Yeah, circle the pivot row. The row with the minimum ratio. Kibet, you must be one of my very best students. Brian, take minimum as pivot row. Yeah, thank you so much, Kibet. You don't disappoint. Pick the minimum to get PR. You guys have not even become teachers. So in this case, the minimum here is this 50. So this minimum, circle everything of this. Circle everything. Circle everything of this row, and I call it what here? Call it the PR. Call it the PR. So once I get this PR, there is another P, something that I must identify. There is a unique feature which is so privileged, which has got both parents. It has, in this case here, a father and a mother at the same time. Yeah, it's not times in this case here, some of us, we're not that privileged. So this is really, really privileged. This is number 4. We call it the pivot element. This 4, we call it the pivot element. Call it the pivot element. Now, once you've identified the pivot element, then now you are at a very good position of doing the next table. So go ahead and do the next table for us. Go ahead and do the next table for us. So we have here x1, x2. We have s1, s2, s3. We have z. We have right-hand side. We have right-hand side. We have right-hand side. So we have 4 rows. So 1, 2, 3, 4. All right. Now, ladies and gentlemen, here we are. So which row am I going to transfer to this table first? Because there must be a first row to be brought here. Yeah. Which row are we going to transfer here first? There must be a first row to be brought here. Yeah, it's called row 2. It will be this row 2, the primary, the pivot row. So pivot row is the one we shall bring here. Pivot row is the one we shall bring here. So remember, this is row 1, row 2, row 3. So 1, 2, 3, and then we have our Z. So pivot row is the one we shall bring, but we don't bring it here the way it is. We shall bring it in position row 2, but not with the same numbers. So as we carry it from here, we are aware that the pivot element must always be equal to what here? The pivot element must always be equal to what here? To 1. So currently I can see this 4. So I must do some abracadabra. The abracadabra will be to divide each pivot row element by 4. We divide each pivot row element by 4. Yeah. So if that is the case, could you kindly give me the numbers to write here in row number 2? So 4 divided by 4, this gives me 1, right? This gives me 1. Somebody give me this answer very fast. 2 over 4, that must be 0.5. Somebody give me these numbers very fast. So this is 0. This is a quarter. This is 0. This is 0. And then lastly, this is what here? That is 50. That is 50. That's 50. And then once we transfer these row there, being the very first row of this table, we must baptize it. There is a name we shall call it. There is a name we shall call it. Is there somebody? Reference row. Thank you so much, Faria. There are ninjas here that I should be able to give gifts. Ninjas who have come to demystify this subject. They are showing other students that, this subject is doable. They are very, very good students. Very good. Ladies and gentlemen, from there we have missing rows. Like now, this is a missing row, isn't it? This is a missing row. Row number 1 is missing. So is there someone who can get ahead and calculate for me this missing row? So the missing row, someone who can go ahead and calculate for me the missing row. Like row number 1, my good students, this is really missing. This is really missing. So row 1 is missing. So this row 1 that is missing, row 1 that is missing. So of course we have here x1, x2, s1, s2, s3. Then we have z if you wish. Then we have in this case here right hand side. If you wish, you can write them. Yeah. So you take the old row 1. So we have old row 1. So the old row 1, what do we have here? We have 2. We have 3. We have 1, 0, 0, 0. Yeah. And then we have 200. Remember, as I'm doing these calculations, I don't have the ratios, remember. So then I'll come and say the row reduction, the big minus, something times reference. What is this something that I'm going to pick? What is this something that I'm going to pick out of this? To know what I'm going to pick out of this, I will identify where the pivot column is. You can see the pivot column is in X1. Pivot column is in X1. So the number in this row that is in X1, this is where we have my pivot column here. So which number am I going to pick times the reference? Yeah, they're telling me 2 times the reference. Thank you so much. And the reference is here. So you just pick the number in the pivot column in this row. Yeah, so 2 times the reference, abracadabra, this gives me 2. This gives me 1. This times 2 is 0. This times 2 is 0.5. This times 2 is 0. The next one times 2 is 0. The next one times 2 is 100. So please go ahead and do now the reductions. So the reductions, so here we have a 0. Here we have a 2, isn't it? Here we have a 1. Here we have a minus 0.5, a 0, 0, and then a cool 100. A cool 100. So this is the new row 1. This is the new row number 1. The new row number 1. So new row number 1, we have 0, 2. 1 minus 0.5. 0, 0, 0, 0. And then we have 100 there. We have 100 there. So we have new row 1. Now we want to get new row 3. Now we want to get new row 3. Is there someone who thinks they are in a position of getting new row 3 by themselves without my help? Anybody, just by mentioning why for yes? Who is very certain is saying that, I mean, if you give me a chance of getting this row number 3, we can get it. Yeah, wow. Beautiful guys. Great students. Normally this Mwalimu Aurea, Dr. Aurea is privileged to have the very best students at RCM. Yeah. Yeah. So many people in Kenya will fear this simplex, but now you guys are on top of things. On top of things. You're on top of things. So let's do row number 3. Row number 3 together. So this row number 3 together, so we say row 3 is missing. So we say old row 3. Old row 3. So you don't have to write those X's so long as you really are quite aware. So this is 1, 2, 3. So the old row 3 is 5, 3, 0, 0, 1, 0, 400. Don't write the ratio, remember. Don't write the ratio. So from there, you'll come and say minus something times reference. This something is what now defeats so many people. What is this something number? What is this something number? Once you know the something number, then you can never go wrong. Once you know the something number, you can never go wrong. You can never go wrong. Yes, you ask yourselves, amongst all these numbers, which number is in the pivot column in row number 3? Which number is in the pivot column in row number 3? It is this. You know there's a pivot column. So I can pick from row 3, this 5. This is the pivot column number. It is a number I want to pivot on. So in this case here, 5 times the reference. So you take the reference and multiply 5, all the elements with 5. So 5 times 1, that gives me 5. 5 times 0.5, that gives me 2.5. This gives me 0. This for sure I will not be able to get. 5 times 0.25 gives me what? 5 times 0.25 gives me what now? 5 times 0.25 gives me what? 5 times 0.25 gives me 1.25. Thank you so much. 1.25. Thank you so much. Then we have 0, 0. And then we have 5 times 50. That gives me 250. Do the row reductions now. Do the row reductions now. So then these will be able to give me new row 3. So new row 3, I have a 0. I have a 0.5 when I subtract a 0. I have a negative 1.251, This gives me 100 what here? This gives me 150. 150. All right. So we have here new row 3. This is 0. This is 0.5 minus 1.25. We have a 1 here, a 0 here. Did I skip something? We have a, okay, so 0, 0.5. Yeah, I skipped 0. So 0.50 minus 1.25. Then we have 1. Then we have 0. And then we have 150 like that. And then now we go to the last Z row. So now we are working on the last row. We are so privileged. The last row, we are so privileged. The last row, we are so privileged. We are so privileged. So this last row, what do we have here, ladies and gentlemen? So we talk of the old Z row. So old Z row, what do we have here? I can see it is here, minus 3,000, minus 2,000, 0, 0, 0, 1, 0. Yeah. Then we come and say minus something times a reference. What is this something? What is this something in this case? You ask yourself, out of this Z row, is there any number which happens to be in the pivot column? Yeah, pivot column is very, very important. Is there any number that happens to be on the pivot column? Any number which happens to be on the pivot column? Wait, they're not talking to me. They aren't talking to me. They are minus 3,000, yes. This minus 3,000 is what happens to be in the pivot here. You can see this is a pivot column. Yeah, so in this case here, minus 3,000. You pick it with a negative. So minus 3,000 times the reference. So the first one will be minus 3,000 because it's minus 3,000 times this one. Minus 3,000 times this gives me minus 1,500. Minus 3,000 times this gives me 0. Minus 3,000 times 0.25. Can somebody give me this? Minus 3,000 times 0.25. What figure are we getting? Minus 3,000 times 0.25. What figure are we getting? Minus 750, right? So we have here minus 750, minus 750. Then we have in this case here 0, 0, 0, 0. And then, of course, the right-hand side there, minus quite a huge figure, minus 3,000 times 50. Quite a huge figure there, minus 3,000 times 50. Minus 3,000 times 50 will give us what figure? Please talk to me. Minus 3,000 times 50 will give me minus 150,000. Thank you so very much. 150,000 negative like that. So go ahead and subtract. So the first one you have to be very, very careful. Because you see now we have minus 3,000 and then we have this minus and then minus 3,000. Using your calculator, minus 3,000 minus 3,000 will end up giving me what figure? Will end up giving me what figure? I'm told 0. So I'm told this is 0, 0. And then we have here minus 2,000 minus 1,500. You know that will be minus 2,000 plus 1,500, which gives me minus 500. Yeah, that gives me minus 500. So long as you use your calculator very well, you simply say minus 2,000 minus 1,500. We'll be able to give you the correct answer, which is minus 500. So this gives you 0. This gives you 750, 750, 750. This gives me 0. And before I continue, I would want to know, could we be having any student here from my physical classroom? You know, I have some students here from physical classroom. That is at Commonwealth House. Could we be having any student from that group that has joined me here today? By any luck, from Commonwealth, who has been able to join me here today? Somebody who is attending my physical classes, but today they are here with me, even if it's one student. Even if it's one student, do we have such a student here today from Commonwealth? If you are the one, simply mention there, Y for yes. Seems nobody. I thought there should be. I sent the link there. I sent the link there. We shall overcome. We shall overcome. All right. So then minus 3,000 times this was that give us 750. No, we are subtracting. So this gives us 1, and then this gives us 150,000. 150,000 like that. This gives us 150,000. Thank you so much. So now we have our Z row. So Z row, we have 0, minus 500, then 0, minus 750, 0, 1, and then we have here 150,000. So then now we have a complete table. What do we do with this table? What do we do with this table? What shall we use this table for? What shall we do with these tables? Can someone talk to me? You test for optimality. Brian has also been very consistent in my classroom. Brian has been very consistent. Every complete table shall be assessed for optimality. And what we are able to see is that even this new table is not optimal, isn't it? So remember, this was our new table 1. This was our new table 1. So the above table is not optimal. The above table is not optimal. We experience some sort of loss. I love that language, Lazarus. Thank you so much. We have a loss here in the Z row. In the Z row. Don't talk about these other losses. We have a loss in the Z row. So the above table is not optimal. That's what you write. I'm not writing myself because of the size of my board. The above table is not optimal. So if it's not optimal, what shall we do? We shall identify the highest loss. We shall identify the highest loss. So the highest loss, ladies and gentlemen, that we can see here right away, the only loss actually is this one here. This is the one. So I want in this case here to do an intervention on this loss. At least I did an intervention here and I'm okay with this side. So again, I want another intervention. So come here, this is the highest loss. This one here you circle. You identify the pivot column. Very, very important. Pivot column to help me get the ratios. So ratios now, you're taking this right-hand side numbers, you divide by this, by the pivot column. So we have 100 divided by 2. This gives me 50. 50, isn't it? Yeah. Then we have 50 divided by 0.5. Oh, yay. 50 divided by 0.5. What figure are we getting? 100. 100. So this gives us 100. Thank you so much. 150 divided by 0.5. 150 divided by 0.5. 150 divided by 0.5. That gives me 300, right? 300. Thank you so much. Then remember, we do not calculate a ratio for the Z. Don't calculate ratio for the Z. So remember the ratios, we shall always go for the minimum. For the very least, the minimum is this 50. You circle the whole of this row. Circle the whole of this row using a different kind of a pen. Could it be black or blue? Not write in the exam. So you circle with that, ladies and gentlemen. And this row, we are going to call it a pivot row. We are going to call it a pivot row. Yeah, and the pivot row and the pivot column, where they meet, we have what we call a pivot element. Call it capital E, pivot element. It's a very, very important element. Yeah, and then we can do new table 2. So now we can do new. I promise you this will be optimal, eh? I promise you this will be optimal. So new table 2. So we have X1, X2, S1, S2, S3, Z. Then we have right-hand side values. 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 So remember, it is pivot row that we start by bringing here, right? Always, the new table, you bring the pivot row, but always, you shall ensure that this element, pivot element, is 1. The element that we have here is 2. And I want, in this case here, the element to be 1. So basically, the pivot row to be divided by 2 throughout. By 2 throughout. You divide by 2 throughout. I wish I had kind of blue pen. By 2 throughout. So then if I do that, my good students, the first value here, remember this is row 1, eh? pivot row is, so it will come here in row 1. It will come here in row 1. So we have 0 there. We have in this case here 1. We have 0.5 here. We have minus 0.25 there. All right. So then we have a 0. We have a 0. We have 50 there. So this is what we shall now call the reference. Always use this side to name. This is what we shall call the reference. So row number 2 now is missing. Row 3 is missing. Row Z is missing. So come here, ladies and gentlemen, and they give me row 2 now. Give me row 2, working for row 2. So you give me the old row 2. So old row 2 is this one here, which was the reference in the other one, but now here it is an old row. So old row 2 here, we have a 1, a 0.5, we have 0, 0.25, we have 0, 0, and 50, like that. So you shall be able to come and say, minus something times reference. What is this something that I should be able to pick out of this? Minus something on row 1. I can't get that question very well. Are you asking why I brought this row 1? You know, here it's pivot row is on row number 1. Eh? So we bring it in row number 1 here. In row number 1. So is there someone who can tell me in this case here, it will be something times reference. What is this something? What is this something? Yeah, 0.5. Because you simply ask yourself, where is the pivot column? Pivot column is here. In my row number 2, the element which is under pivot is this one. Thank you so much. So 0.5 times the reference. Which reference are we talking about? Now reference here for the new table. Reference for the new table. So 0.5 times all these numbers. So the first one will be 0.5. No. The first one, no. The first one is, the second one is 0.5. So 0.5 times the reference. This gives me 0.25. This is so huge. Don't even want to know it. So 0.5, now I can know it. It is 0.125. So this gives me what times 0.5? This gives me what times 0.5? This gives me what times 0.5? Minus 0.125. Thank you, Lucy. Minus 0.125. So then this becomes 0, 0. This times 0.5 gives me 25. Go ahead and subtract for you to give us new row 2. For you to give us new row 2. So this gives me 1, 0, minus 0.25. How about this? This will be 0.25. There is like a minus here. Minus here, the number itself is minus. So in my calculator, I'll say 0.25 minus 0.125. 0.25 minus 0.125, which will end up giving us a what figure? Which will end up giving us a what figure? Which will end up giving me what figure? Which will end up giving me 0.375. 0.375. This is 0, this is 0, this is 25. So I'll be able to come and put these new row 2 figures here. So we have a 1, 0. We have a minus 0.25. We have a 0.375. We have a 0, and then we have 25. And then now we look for row number 3. Please kindly try getting row number 3 by yourselves. Look for row number 3 by yourselves. I'll give you 5 minutes. You give me this new row 3. You give me this new row 3. I'll give you 5 minutes. Try giving me row number 3. Try giving me row number 3. I will give you 5 minutes. Try getting this row number 3. Row number 3, just imagine, put down your figures, you will be correct. Put down your figures, you will be correct. So we have old row 3. Old row 3. So the old row 3, I can see it here. It is 0, 0.5, 0, minus 1.25, 1, 0, 150. Then I come and ask myself here, which element is under the pivot? You can see this is pivot column. So the pivot column again, we happen to be having the pivot here, 0.5. So I will say minus this 0.5 times the reference. I rubbed minus 0.5 times the reference in the new. Reference in the new, what do we have here? So the first one is 0, 0.5. Then we have 0.25. Yeah, this one is what you guys gave me, minus 0.125, if I'm not wrong. This one is 0, 0. This one here was 25, like that. If I'm not wrong. If I'm not wrong. Same figures, basically. So this will be 0, 0, minus 0.25. So minus 1.25 minus 1.25 minus that number gives me what figure? Somebody is giving me a figure here. Minus 1.125, right? Minus 1.125. Thank you so much. 1, 0, 125. So this is what I write here as my new row 3. As my new row 3. So my new row 3 will be 0, 0, 0, 0. Then we have minus 0.25, minus 1.125, 1, 0, 125. From there now we go to the Z row. So the missing Z row, the last one. The missing Z row, the last one. So the missing Z row, the last one, what do we have here, my good students? So can I rub this? Can I rub this? Can I rub this? Can I rub it? Can I rub this? All right, let me rub it. So now we are onto the Z row. We are onto the Z row. We are onto the Z row. So come and give me the old Z row. The old Z row. So the old Z row, what do we have here, old Z row here? So 0, minus 500, 0, 750, 0, 1, 150,000. Great. So out of these numbers, I can see the one that is circled, the one that is under the pivot. This is the one that I would want to kill tonight. So I say minus this number, which is minus 500 times the reference. Minus 500 times the reference. So minus 500 times this gives me 0. This gives me minus 500. This gives me minus 250. Yeah, so the next one, of course, you guys have to be kind enough to me by giving me the answer. Minus 500 times this minus 0.25. So that will be positive what? That will be positive number 125. 125, thank you so much. And then minus 500 times this. So this is 0, 0. And then we have this huge figure. Minus 500 times this 50. So that gives me minus 25, 2 zeros plus that 0. Minus 25,000. Is that okay? Minus 25,000. Thank you so much. So go ahead and do your row reductions. Go ahead and do your row reductions. So we have here the new Z row. So this gives me 0. This will be minus 500 minus 500, 0. This gives me 250. How about this one here? 750 minus 125. 750 minus 125. Thank you very much, Miss Wambua. You don't disappoint. You have been at the forefront of this 625. So 0, 1. This is quite tricky. This gives me 175,000, isn't it? The last one will be 175,000. 175,000. Thank you so much. Thank you so much. 175,000. So this is the new Z row. The new Z row, we have 0, 0, 250, 625, 01, 175,000 like that. 175,000 like that. And I'm so happy. Hooray! Why? Because I can see now finality on my Z row. Now I can't see losses. Now no losses at all. So the above table is what here? The above table is optimal. The above table is optimal. The above table is optimal. So even an exam, you can celebrate a little bit, say hooray, if I don't sound too much. Others will be thrown out of the exam room. So say the above table is optimal, no losses at all. And then now we go to the interpretations. We go to the interpretations. So the interpretations, you have to be very, very careful with the interpretations, ladies and gentlemen. Interpretations, you have to be very, very careful. Has no loss, yes. Z row has got no loss, no negative in the Z row. No negative in the Z row. Yeah, so this is really very, very good for us as scientists. Very good for us. Now, ladies and gentlemen, once I get that, so we start with the optimal productions. So optimal productions, very easy. Optimal productions. So we have X1 and X2. So we get it here. So X1, where is the pivot? This, you see 0, 1. So X1, 1 here. But now you go to the other side. So basically X1, we produce how many? 25. X1 will produce 25 units. How about X2 if you're following? X2 shall produce how many units? X2, how many shall we produce? X2. Yeah. So X2, you work with this 150. Thank you so much. That is really, really important. After this optimal productions, go ahead and tell us the resource usage. Go ahead, of course, here we have slacks. Do we have any slack? S1, S2, S3. Yeah, like now you can see S1, 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 nothing. No pivoting. S1, nothing. So nothing will throw me the other side. So S1 is 0. How about S2? S2 as well is 0. Nothing to pivot on. But if you see S3, are you seeing S3 there's a 1? So S3 is 125, like that. S3 is 125. Once you do like that, you've gotten all the marks. All right. And then, of course, we have the optimal profit. So we have here the optimal profit, optimal profit, optimal profit. The optimal profit is the final figure of Z, which is 175,000. 175,000. And then, ladies and gentlemen, we have here, very, very important. We have here, very important. We have here, very, very important. So I don't know whether you've finished writing this. I can wrap this. Yeah, on the slacks. Remember, you see this is slack 1, slack 2, slack 3. So it is only slack 3 that has a unit T. It's only slack 3 which has 1 here. So S3, 125. But all the others, there's no 1 here. You know, for the solution to be there must be like this X1, there is a 1. Then you read the solution like that. I hope that is okay. So they're telling me, yes, I can wrap this. Yeah, great. Great. I repeat on optimal production. Optimal production. Optimal production is very, very easy. You know what was the quantities of our products? It was X1 and X2. If you remember, I can't remember whether we had S-corn and something. S-corn and something. Yeah. So in this case here, we have here X1. We have there 25. Just give me a minute. I followed some teacher here. I'm told that I'm using this link. So from there, you're supposed now to come and remember this X1 and X2, the 2 here in the Z gives us what we call reduced cost. Reduced cost. And these slacks, in this case here, we have what we call shadow prices. Shadow prices. Shadow prices. This S1, S2, S3. I will start from there in my next class. Otherwise, I hope you've been able to pick something, however small. Thank you. And of course, those ones who are following me on YouTube, and ensure that you're subscribing